All right, let's do it. Let's get on day 4. Have a calculator ready because we have to continue on in our stats unit. All right, I'm going to start class today the same way I started this unit, which was I want to figure out the average amount of sleep somebody in town gets. And you guys have learned a lot so far. You guys have learned what the word population means. And in my example, and you don't have to copy this down, I'm just trying to intro today's topic. The population is what? The town of Bethlehem. But what's the problem? Trying to figure out the amount of sleep everybody gets. Way too many people. I think somebody had some spare time in first period and said it was like over 8,000 people in town. Okay, I'm not getting 8,000 people. So I got to take a smaller size, which is called my sample. So let's see. I'll go 600 people. All right. So I survey 600 people and say, hey, how much sleep do you get tonight? How much sleep do you get tonight? And I find the average from those 600. And let's say the average from that sample is, I don't know, what do you think? 6.5? 6.5 hours a night? You want to go 7? All right, 7 hours a night. There's a little problem with that, though. That's just for these 600, right? Do you think it really represents the whole population? Maybe, right? Maybe. But I could be off, couldn't I? All right, I could be off. Now, the question is, how much am I off by? How much am I off by? That's what we're going to find today. Am I off by a half hour? Plus or minus a half hour either way. Am I off by maybe 1 hour either way? But are we all in agreement that 7 hours does not represent the population? So I want to find out, well, how much am I off by then? All right, how much am I off by either way? A lot of you guys have seen this when it's time to do elections in November. Have you seen this maybe on the TV or on your phone? When they ever say how many people or what percent voted, they always have this little thing maybe in the bottom corner that says margin of error. That's what we're going to find today. And here's what margin of error is. 42% of people didn't vote for candidate A. That 42 could be off by 2.4% either way. So really, it could be anywhere between, let's see, subtract 2.4 and add 2.4. It could be anywhere in between there that voted for that candidate, but it's not 42. All right, so that's what we're going to find today, which is the margin of error. Questions, which is how much is your sample off from your actual population? Questions? You ready to do it? Because we're just going to rep the heck out of these problems today. So how do I find this margin of error? I guess I got to add more color to it, huh? That was pretty cool. I got to add more color to my slides. How do I find my margin of error? I'm always going to abbreviate it MOE so we don't have to write out the words margin of error every time. Mo. Great job, Maddie. Sorry. Great job. I'm glad we could read. Good. Next step, do the math, right? I'm just like, I can't move on right now. What? Because you want to know why? Because this is the first time I'm seeing your face all year, your actual mug all year, and it's like you guys as a teacher, you guys have no idea the effect the masks have on me. I saw a student I had last year, the entire year I taught her last year in my geometry class. I saw her in Price Chopper. She goes, "Hey, Mr. Carlino." I turn around. If she didn't have a jacket with her last name on it, I would have had no idea, because that was her without her mask. I would have no idea. It's just, I walk past kids in the hallway. They're like, "Hey, Mr. Carl." I'm like, no idea who you are. Even though I probably taught them last year. No idea. It's sad. It's sad. But whatever. It is what it is. So sorry, Maddie. Sorry.
I can't stop right now. Shocked at how ugly you are. No.
All right, so moving on. How do I find the margin of error? It's an easy formula to remember. Easy. I do plus or minus 2 times whatever the standard deviation is. All right, and that's what's in that text box right there. So I'm going to do plus or minus 2 times the standard deviation. All right, so let's just jump right into it. So they're doing a study on the mean weights of residents in a certain town. Ooh, you're playing with fire there, huh? Why would you do that anyway? But and we only sampled 86. Only sampled 86 in the town. Mean weight was 168. Standard deviation is 25. And I'll get to this 95% confidence level here in a second. I'll get to that when we start figuring out. Find the margin of error for me for the mean. Find the margin of error. All right, so here we go. The margin of error is going to be plus or minus 2 times, what was my standard deviation? 25. Margin of error will be, keep the plus or minus 50. And again, what does that mean? Well, your sample had a mean of what? 168. But the town's mean weight might be 50 above or 50 below that 168, somewhere in between. That's what this means. Okay? Yes, the sample had a weight of 168, but the entire town might have an average weight somewhere 50 below to 50 above that. That's what the margin of error tells me. And we'll actually find that interval here coming up. All right, how about your SAT scores, number 2? They sampled 64 seniors. They found a mean score of 463. Standard deviation of 92. Find the margin of error for the mean. All right, pretty easy finding the margin of error. Plus or minus 2 times, where's my standard deviation? 92. So the mean could, the mean of the entire senior class could be anywhere plus or minus 184 points above or below that 463. That's what the mean could be of the entire senior class there. Because it's not 463, I can tell you that. But it could be 184 above or below that.
You got 184.
2 times 192?
2 times what?
2 times 92. Right? I'm just doing 2 times the standard deviation. All right, go ahead. Try out 3 on your own. Because then I'm going to get to something different with 4. Number of we discussed this, by the way, first period. Average number of texts a day, 196. Is that like
No, it's like
too high? First period said they wouldn't blink an eye if they heard that.
I don't know.
That's
They
like if
wouldn't
you're
blink an eye.
popular.
Me, the old guy,
Like,
I'm happy if I get the double digit.
I have
do have commercial
absolutely
series.
no one to talk to that much on text.
Like I'm just thinking today already. I might be at 8, I think.
The only person who texts me is my fake grandma.
Why is she free?
Because she's not my real grandma, but I call her name now.
My grandma.
I just
So we're doing plus or minus 2 times 53, which gives me the margin of error plus or minus
Plus or 9.
106.
Wasn't that?
Go ahead, Lizzie.
Have the margin of error be equal to the mean?
What do you mean?
Like, what if it was 196?
That could happen.
It could.
That just means, remember, the margin of error just tells me the actual mean could be plus 106 in this direction or minus 106 in the other direction. It has nothing really to do with what the mean would be. Okay? All right, anything here? Okay, let me try to make you think a little bit. Oh, actually, we're not even there yet. Never mind. I thought we were doing something different. All right, now that you know what it could be off by, let's actually find the range of scores or values that the mean could possibly be in. This is called our confidence interval. And not only that, it's going to be a 95% confidence interval, which I'll get into what the 95 means in a second. But let's actually just find the interval. And how do I find the interval? After you find your margin of error, you add and subtract it from the mean. All right, you add and subtract it from the mean. Let's just find one, and I think after I describe it, it'll be a little bit better. So, yep, determine the amount of money each student saves. They find that the 66 students they sampled, the average was $3,500 they saved. Standard deviation of 500. What's my confidence interval now? Meaning, give me an interval of numbers where the population mean could possibly be. So first thing, got to find the margin of error. 2 times, what's our standard deviation? 500. So my margin of error is going to be plus or minus 1,000 either way. Now we take this one more step, and now we find what's called our confidence interval. CI, I'm going to abbreviate it. And this interval will be where this mean will actually be. So I take the mean, which was 3,500, and I do plus and minus 1,000. Lower number goes first on the interval, remember? So 3,500 minus 1,000. 2,500 to 3,500 plus 1,000, which would be 4,500. All right, let me stop right there. Here's what it means. We are 95% confident. We are 95% confident that at this local high school, the average student saves between 2,500 and 4,500. We're 95% confident they save somewhere in between that. Okay? On average. All good? It's pretty good confidence level, 9,500, or 95%. All right, let's go back to the weights in town and find our 95% confidence interval here. Got to find the margin of error before I find the interval. So plus or minus 2 times. What are we multiplying the 2 by here? Plus or minus 2 times. What do you got? 20? I'd go to the numbers, but it's worthless today. So my margin of error could be plus or minus 40, either way around the mean. So now my confidence interval. My mean, which was 168, plus or minus 40. So we're going to be 95% confident that a person in this town weighs between 128 to 208. Could somebody fall outside that range?
Yeah.
Yeah, and we'll talk about that on Monday, the unusuals. All right, we'll talk about that on Monday when it falls outside. Questions here? You guys got number 3 on your own. Go ahead, number 3 on your own. 283 to 671? Okay. So, no? You good back there, Goof Troop?
Yeah.
I know you're missing a member, but only 2/3 strong today. And I'm sure you'll be watching this recording, right?
Yeah.
Mm-hmm. Let's say my confidence interval is not in 95% for that one. All right. Just love throwing Mr. Carlino in the roaster, huh?
I'm sorry.
I just hope we can take it when the time comes.
Oh.
I hope you dish it, you should be able to take it. That's my
You were calling
philosophy.
me ugly earlier, so I mean, I don't know.
When did those words ever come out of my mouth?
Well,
Now you're just making my stuff up.
Mask off.
You're like, wow, I need to take a minute.
Sorry.
You guys are like a comedy duo over there.
We're like the old guys on the
Yeah.
On the Muppets.
What is it, like Rupert?
Stop.
Good times.
The old guys who sit on the balcony.
Yeah,
and-
yeah.
I have to
Yeah.
watch
Yeah.
the Muppets.
Yeah. All right, little change up for you now. Little change up. Now a little multiple choice. What score would be a reasonable value for the true mean here?
The true.
All right, the actual. We're never going to find it. We're never going to find the true mean unless we survey everybody, and that's not going to happen in a huge population. So which one could possibly be a true mean here? Well, I got to find a confidence interval. And be careful here. Do I need to find the margin of error? No, it's already given. I got to read carefully. So I'm going to go right to the confidence interval and figure it out by saying a mean of 503 plus or minus 23. So the true mean should be where? Somewhere between 480 and 526. And thankfully for us, only one of those values could be the true mean.
It's D.
How? Oh. How?
3 of them don't fit in the interval. 1 does.
I got it.
Good deal. All right. See what you can do on this one. Now I'm going to give you the confidence interval. What was the margin of error? Oh. So I got a confidence interval of 56 to 62. Oh boy, how are we going to figure out the margin of error? I don't want to give this away and just feed it to you either. Remember, the margin of error is what I add to the mean, both sides, the same number, both sides. I know. My interval's 56 to 62.
Oh, we just have to. Never mind.
Go ahead. No, Lizzie, go ahead. What do you got?
Divide by 2.
What do you mean divide by 2?
Divide both of those with the 200. And 56 minus 62 divided by 2.
Where's that going to get me?
Do we have?
What did they give you?
Well, how far apart are these?
Do we have?
There's 6%, like 6% in between them, right?
Yeah.
Everyone agrees? So if it's 6% between them,
Is that the standard deviation?
no. If there's 6% in between them and I need to figure out what I need to add to the left and to the right.
Add.
Okay, well, let's do it this way. Let's do it this way. Because we did this way first period that came up. What is in the middle? What's in the middle? 59, right? So you tell me now. What do you have to add and subtract to 59 to get 56 and 62? 3. There's your margin of error, 3.
That's what you get if you divide by 2.
Okay, so we're finding, the other way is yes, find out how far apart they are, which is subtracting them, 6, and divide that by 2. So yes, the margin of error is 3%. Not just, whoa. Not going to accept this, right?
3%.
No. Put it over.
No. What am I missing here?
What?
I'm not going to accept margin of error
Oh,
equals 3%
we need
because
a-
then I just
we
get
need a-
62. I wouldn't get 56. Plus or minus. There you go. All right, play around with the next one. 64 and a half to 69 and a half. However you want to accomplish this. Don't, the middle one is not your margin of error. It's how you got there. So 64 and a half to 69.5%. What must have been my margin of error?
What do you think? This girl at the camp looked at my mother and said, "You go out and publish like that?" She said that.
What do we have? What do you think? Margin of error?
2.5.
What?
Plus or minus.
Well, they're 5% in between them. So what would I need to add and subtract from my middle number to get there? Not 5.
2.5.
2.5.
2.5. Yep.
Wait, that's what I said.
You said 5.
No, I was answering what she said 2, and then I said 0.5. I did, and then I said plus or minus 2.5.
I'm sorry, I just blacked out as soon as you started talking. Whatever you said.
I'm having a clue.
I did get it right.
I haven't a clue.
Good job, babe.
We're all good? All right, let's finish up on these two. I do want to expose you to these right here because we'll be working more on these on Monday. I don't know if you've ever seen these before, but these are called dot plots. Okay, these are called dot plots.
I call them scatter plots.
And they're not scatter plots. Scatter plots are on an actual graph. These are called dot plots.
Oh, I'm sorry, guys.
Okay. But I am giving you the mean and standard deviation though of this dot plot, so you don't have to figure it out yourself in your calculator. So the mean's 0.502, standard deviation 0.046. Find the margin of error in the confidence interval. Same thing, plus or minus 2 times. In this case, which one do I use? 0.502 or 0.046? Standard deviation. So I get plus or minus 0.092. Pretty small margin of error, huh?
Killed them.
Pretty small.
Killed it.
Now go ahead, find your confidence interval. Take your mean, plus or minus 0.092. So it'll be anywhere between 0.41 and 0.594. So look at that little one over there, a little outcast, huh?
Yeah, loser.
Hey.
There's so many things.
Sorry, guys, I've been having a long day.
Go ahead, try out number 8. And I got one more thing I need you to jot down before I let you go and practice. Good thing they give you these values and we don't have to type them all in a list, huh?
Yeah.
0.41, 0.41, 0.41. We could still do it if we had to, but. Here's my question, and we'll write this down when we figure out an answer. If I sampled more and more and more people than I have right here, do you think my margin of error decreases or increases? The more people I sample,
Oh no.
the more people I sample, more and more and more. What do you think happens to my margin of error? Did you just look that up on Google? What do you think? The more samples I get, the closer I'll get to the actual mean. So yes, so go back to the margin of error formula at the beginning of the notes on day 4. Larger the sample, the smaller the margin of error. Okay. You have plenty of time. You probably will get this done. Go ahead. Have your Chromebooks open to the answer key. You just gotta, I have 8 questions. Let's do this. Jenna?
How you do this?
Okay.
How you get 2.5?
Okay. So right now these are 5 apart.
I put it up because I
Agree
was
with me?
dissecting a chicken.
So halfway
Chicken?
would be the score that's 2.5 away from this one and 2.5 away from this one. Agreed with me? If I found the actual middle score, I have no idea how it is. But if I found, like here, the middle one was 59. This is an easy one to do because they were 6 apart. I went 3 from each. 59 is in the middle, right? So margin of error is how far from the mean is it this way and how far is it from this way, and they're both 3, which they should be. So that's how I get to 3. So I just find out how far apart they are, and then where would the halfway point be? Okay? You're welcome. Good question.
Chips in a random sample. How are you supposed to figure out the first one? Watching the videos when you're home and like blasting it because